Okay, let's go ahead and talk about the division properties of exponents. Okay, so we learned that when you multiply together two powers that have the same base, like x to the fourth times x to the third, you add the exponents together. So we get x to the seventh power. Well, since division is the inverse of multiplication, then what that means is when you divide powers that have the same base, instead of adding the exponents together, you subtract the exponents. Okay, so let's go ahead and take a look at what that looks like with some of these examples. Here in example number 1, we have 5 to the 6th power divided by 5 to the 2nd power. Okay, now if I were to write that out, it would look like this, 5 times 5 times 5 times 5 times 5 times 5 divided by 5 times 5. And if we cancel out these 5s, what am I left with? 5 times 5 times 5 times 5, or 5 to the 4th power. So that's exactly what happens here. If I have 5 to the 6th power over 5 to the 2nd power, and I subtract the exponents, what's 6 minus 2? 4. So that's how we can get to that, all right? So 5 to the 6th power divided by 5 to the 2nd power is 5 to the 4th power. Okay, next example, we have here x squared divided by x to the 5th power. So again, we're dividing and we have the same base, so we have to subtract. Now you always need to subtract in the order of top exponent minus bottom exponent. So don't do 5 minus 2. This has to be 2 minus 5. So what is 2 minus 5? Well, 2 minus 5 is negative 3. So x squared divided by x to the 5th becomes x to the negative 3rd power. And we already know what to do with that negative, right? It means reciprocal. Negative exponent means reciprocal. So I need to rewrite this as 1 over x to the 3rd power. Next example here, I'm going to show you two different ways to kind of think through this one. Okay, these could be very tricky because sometimes we have a tendency to mess up on double negatives. So here we have y to the 3rd divided by y to the negative 5th. So again, we're dividing and we have the same base, so we subtract, and it's always top exponent minus bottom exponent, right? So think about what 3 minus negative 5 is. If we look at it, 3 minus negative 5, correct? Well, what do we have? Whenever we have minus a negative, this becomes a positive or a plus sign. So we end up doing 3 plus 5, which we know is 8. Okay, so our answer is y to the 8th power. Our simplified expression is y to the 8th power. Well, what's another way to look at that? We already know, let me write this again down here in blue. Okay, y to the 3rd power over y to the negative 5th power. So if we take a look at this y to the negative 5th power, and we know that when you see a negative exponent, you change places, you move it, right? So if I have a y to the negative 5th power down here at the bottom of this fraction, I know I can rewrite this fraction and move it to the top. So y to the negative 5th moves to the top and becomes y to the 5th power. Well, what about y to the 3rd? Y to the 3rd isn't moving, y to the 3rd stays. So we got y to the 3rd, and down here's a 1. And so what is y to the 3rd times y to the 5th? When you're multiplying powers that have the same base, you add the exponents together, and 3 plus 5 is 8. So we end up with y to the 8th power. Okay? So once again, it uses two different ways to look at this problem. Either 3 minus negative 5 becomes 3 plus 5, which is 8. We get y to the 8th power. Or if you think about it, the way we've talked about moving terms with negative exponents, so the y to the negative 5th moves to the top as y to the 5th, and then you get y to the 3rd times y to the 5th, which becomes y to the 8th. So two different ways to get the same correct answer, to end up with the same simplified expression. So let's take a look at now example number 4. If we do example number 4, the first way I talked about, z to the negative second divided by z to the negative fourth, okay, we end up subtracting the exponents, top exponent minus bottom exponent. So we have here negative 2 minus negative 4, which becomes negative 2 plus 4, which equals 2. So we see that z to the negative second divided by z to the negative fourth simplifies to z to the second power. If we do this the other way that I just talked about, okay, we see that we have a z to the negative second divided by z to the negative fourth, and they both have negatives, so we're kind of going to switch places. So z to the negative second is going to come down to the bottom, and z to the negative fourth is going to move up to the top, and it becomes z to the fourth over z to the second, and again we subtract. What's 4 minus 2? 2. So again, here, two different ways to arrive at the same conclusion. I tend to like the first version because to me it's less work. But if you struggle with the double negatives and the switching places makes more sense to you, by all means, go ahead and do it that way. All right, 3 more examples. Number 5, 4/7 to the negative second power. For some of us, we get a little confused because some of you, whenever you see fractions, you're like, oh no, it's a fraction. You know, the world is coming to an end, but you don't need to do that. You already know what to do with a negative exponent. What does the exponent of negative 2 tell you to do? It tells you, get the reciprocal of this. What's the reciprocal of 4/7? 7 over 4. So now this becomes 7 over 4 to the second power. Remember, that means 7 over 4 times 7 over 4. Top times top, bottom times bottom. 7 times 7 is 49. And 4 times 4 is 16. So this right here, this is our simplified expression. Now, if you take a look at number 6, number 6 can be a little scary, can be a little confusing, because you might be thinking, wow, I have to do 12 times 12 times 12 times 12, right? Because we have to distribute the exponent of 4 to this 12, right? So 12 times 12 times 12 times 12, that's big. Or down here, 15 times 15 times 15 times 15, that's big. But let's stop and think for a minute, because we know about simplifying fractions, correct? If you had the fraction 12/15ths, what would you simplify that to? I could divide both 12 and 15 by 3, so this would become 4/5. So that's exactly what I can do up here. I can rewrite this now. Instead of being 12p to the third over 15p, I could simplify this to 4p to the third over, not 15, sorry, I messed up there. Not 15, but 5p. And then I have to raise this to the fourth power. Well, it's a whole lot easier to do 4 to the fourth power than 12 to the fourth power. Let's take a look at this. What's 4 to the fourth power? 4 times 4 times 4 times 4 is 256. And then distribute this 4 to the 3. What do we do here? When you raise a power to a power, we multiply. So we have p to the third to the fourth power. 3 times 4 is 12, so this is p to the 12th power. And then down at the bottom, distribute the exponent of 4 to the 5. 5 to the fourth power. 5 times 5 times 5 times 5 is 625. And then p to the fourth power. Now we're not done yet, because we can say p to the 12th divided by p to the, oh, I forgot to put the fourth here. P to the 12th divided by p to the fourth. And we subtract, yes? So what's 12 minus 4? 8. So my simplified expression is 256. 256 p to the 8th over 625. If you're wondering what happened to the p in the bottom, well, that p in the bottom disappeared when I divided. P to the 12th divided by p to the 4th, and then when I did 12 minus 4, that's why this p is no longer down here. So my simplified expression is 256 p to the 8th over 625. All right, so let's go ahead and take a look at this final problem here. This looks like a lot of work. It could look scary, but remember the steps are always the same. You just need to be calm and follow the steps. So what would I do first in my plan of action? I would take care of this negative exponent. We know that a negative exponent means reciprocal. So I'm going to go ahead and rewrite this fraction. I'm going to flip this fraction because I need to do the reciprocal. So the top becomes 5xz to the 5th. And on the bottom, I have 3x squared y to the 5th, z to the negative 2nd, and all of that now is going to be raised. Let me do these parentheses a little bit better. All of that now is going to be raised to a third power. So I have to distribute this third power to everything inside this parenthesis. So let's go ahead and do that. So I have the exponent of 3 to the 5. What is 5 to the third power? 5 times 5 times 5 is 125. Then here we have x to the third power. And here z to the 5th power raised to the third power. We multiply the exponents. 5 times 3 is 15. So this becomes z to the 15th power. On the bottom, we need to distribute the exponent of 3 to the bottom also. So here we have 3 to the third power. No, that's not 9. 3 to the third power is 3 times 3 times 3, which is 27. Then we have x to the second power raised to the third power. Multiply the exponents. 2 times 3 is 6, so x to the 6th power. Y to the 5th raised to the third power. Multiply the exponents. 5 times 3 is 15, so y to the 15th power. And finally, z to the negative 2nd raised to the third power. Negative 2 times 3 is negative 6, so z to the negative 6th power. Okay, now we need to take care of our division. Okay, so I'm going to write it down here. So I'm running out of room. So let's take care of our division. The 125 is going to stay here, and the 27 is going to stay here. And let's take care of now the x's. X to the third divided by x to the 6th. We subtract the exponents. 3 minus 6 is negative 3, so it's going to become x to the negative third power. Now the z's, z to the 15th divided by z to the negative 6th. So again, we subtract the exponents, and this one you're going to be careful. So 15 minus negative 6 becomes 15 plus 6, which is 21. So this becomes z to the 21st power. And the y to the 15th stays on the bottom because there's nothing else. You know, there's no y on the top, so there's no division to take place. So y to the 15th stays on the bottom. So we're not done yet because we have a negative exponent. We have this x to the negative third power. We need to take care of that. We need to move it down to the bottom. So let's go ahead and do that. Again, the 125 is going to stay on top. The 27 is going to stay here. Then x to the negative third is going to move down. And since x comes alphabetically before y, I'm going to go ahead and write that first. So it becomes x to the third power. Y to the 15th is staying because it doesn't have a negative exponent, so it's going to stay right down here. Y to the 15th power. And then on top, we're left with z to the 21st power. And so this is the simplified expression for this problem.